Hello friends, you can log on to primeaptacademy.com to access complete free video courses. Okay, so here there is a geometric progression such that the first term plus fourth term of the GP is equal to second term plus third term of the GP. All the terms of the geometric progression are integers. We need to find that given from the options which of them can be the sum of the first 8 terms of the geometric progression. Okay. So let the first term be a and the common ratio be r, okay, for the geometric progression. So first term plus fourth term, that is a plus a into r raised to 3, okay, a into r raised to 3 is the fourth term. This is equal to second term, that is a into r, plus third term, that is a into r raised to 2. So a cancels out, okay, over here a cancels out, which is the first term. So what we get is 1 plus r cube is equal to r plus r square. Okay, this is what we get. All right. So over here, if you solve this, what we'll get is r cube. Actually, what you can do is you can put r equal to 1. So if you put r equal to 1, it will satisfy this equation. Also, if you put r equal to minus 1, that will also satisfy this equation. Okay. So in fact, if you factorize this equation, what you'll get is r minus 1 whole square times r plus 1 equal to 0. Okay, so from here you will get the roots of the equation as 1, 1 or minus 1. Okay, so the values r can take, the integer values r can take are 1 or minus 1. Okay, so over here the values of r is either 1 or minus 1. So when r is equal to 1, in that case each term will be a. If r is 1, the first term is a, the second term is a, the third term is a, fourth term is a, and so on. So sum of first 8 terms will be 8a. Okay. When r is equal to minus 1, this is when r equal to 1. When r is equal to minus 1, the first term is a, second term is minus a into minus 1. Third term is a, fourth term is minus a, and so on. So if I add 8 terms over here, okay, I am adding even number of terms, that is 8 terms, because we need to find the sum of 8 terms. So that will be a minus a plus a minus a plus a minus a. So all those will cancel out each other. So the sum over here when r is equal to minus 1, sum of 8 terms will be 0. Okay, so 0 is definitely an option here. Whenever r is equal to minus 1, it doesn't depend on the value of a, we can get the sum as 0. Okay. Now looking at the second and the third scenarios, over here definitely r cannot be minus 1, because when r is minus 1, whatever the value of a is, sum is coming out to be 0. Now when r is equal to 1, all the terms are integers. That means a is an integer. Okay, that means 8a should be an integer. Okay, which is the sum. So if you look at it, if 8a is integer, if I put 8a as 370, can we get a to be integer? No, we can't. Okay, so 370 is incorrect. Okay, why? Because if 370 is equal to 8a, a is not coming out to be integer. Okay, but we need all terms to be integer. So a has to be integer. Similarly, if we have 532 as 8a, that will also not be an integer. A will also not be an integer. Okay, so 532 is also incorrect. So basically the sum of 8 terms can be 0 or a multiple of 8. So 370 and 532 are not multiple of 8, because 8a, a being an integer, 8a has to be a multiple of 8. Okay, so over here 370 and 532 are not multiples of 8, so they are incorrect. 0 can be there when r is equal to minus 1. Okay, so only the first option can be correct, is correct. So only one satisfies. Okay, only one satisfies. Alright, that is the correct answer option. Okay, that is how we solve this question.